Alright, so we're going to start off, and again, forgive to MS Paint. I just wanted to get this video out to you tonight. We'll do something more interesting later. We're going to work on problem number 2, part H, and the integral. Let's switch up. Let's get a paintbrush going, right? Oh, so much smoother. So it's going to be from 2 to infinity of 2 over x natural log of x squared dx. This is going to be our problem. Okay. It's important to just categorize the problem. So this is an improper integral. It's an improper integral because it has an infinite interval. Alright, a dead giveaway that we have an improper integral. Well, there's going to be an infinity. Another thing to look for, alright, we also want to look for any discontinuities. Okay, so we see a 0 in the denominator here and here. 1 over x is discontinuous at x equals 0. Okay, and then 1 over ln x squared is discontinuous at x equals 1, but 0 and 1 are not in 2 to infinity, so we don't have to worry about it. So the only thing we have right here is that there's infinity in the symbol. So we always want to check our bounds. Bounds are key, and then we always want to look in the denominator. Alright, we want to check the denominator, see where the denominator is equal to 0. Okay, so we don't have to worry about 0 and 1. That's nice. We're just looking on infinity. Okay. So let's undo some stuff. Oh, that's all I can undo. Great, cool. Okay. Alright, so let's get a good clean palette. Alright, get some happy little variables going. Alright. Okay. So now we're ready to proceed. Okay, so the first thing that we want to do is go ahead, and again, we can't take integrals over infinite lengths. We can only do it over finite lengths if we want to use our Calc 1 skills or any of our Calc 2 skills. We know how to do definite integrals for finite lengths, so let's just make it. Let's make this infinite interval a finite interval. The way we do this, well, instead of going from 2 to infinity, we just go to 2 to t. That's it. But we still would like to know what happens as we go to infinity, so we just let t become arbitrarily large. Okay, it's the same problem. We just do this finite. All right, this is just an interval. This is 2 to t. T is a finite number, and then we let t become unbounded. Okay, it's the same problem, but it is much easier to handle. I don't have to be clever. I don't have to think of anything. I can just go ahead and do my normal Calc 1 skills. Okay. We don't have a rational function, so we're not going to do partial fraction by decomposition. We see a natural log of x. Anytime we see a natural log of x, we want to try u sub. So let's just do that. So du is 1 over x dx. Now we also have to do our bounds. Okay. So when x equals 2, u is going to be natural log of 2. And when x equals 2, u is going to be natural log of t. Alright. So we now have the limit as t approaches infinity. Integral from natural log of 2 to natural log of t of 2 over u squared dx du, which is going to equal the limit as t approaches infinity of negative 2 over u from natural log of 2 to natural log of t, which is going to equal negative 2 over ln t minus negative 2 over ln 2. And we already messed up, right? Because this doesn't make any sense unless we take the limit as t approaches infinity. There we go. All right, let's just remember quickly. The natural log function becomes arbitrarily large as x becomes arbitrarily large. So this denominator here goes out to infinity. Dividing by infinity, the whole term becomes 0. So now this becomes 0 minus negative 2 over ln 2, which equals 2 over ln 2. Okay. Now you always want to check our work. All right. So let's look again. So our final answer was 2 ln 2. But let's look at our original problem. Our original problem was the integral from 2 to infinity of 1 over x natural log of x squared. Okay? And the reason why we're doing this is because more often than not, you're going to plug these limits up here incorrectly. Okay, if you can follow the cursor. These limits you're probably going to mess up, and you might mess up a minus sign. It's very easy to do. It's a common mistake I see in grading all the time. So you want to see if your answer makes any sense. Okay, so let's look at this. All right, so x is greater than 0 whenever x is in 2 to infinity. And natural log of x squared is going to be greater than 0 whenever x is on 2 to infinity. Alright, so 1 over x ln x squared should be positive. Okay? This whole thing, that's good. That's good that we got a final answer that's positive. That makes a lot of sense. Alright, this is the biggest thing. I see minus signs all the time when there shouldn't be, when we get negative answers, when the whole area was positive, so we'll just be very, very careful. Make sure our answer makes sense. Alright? So hopefully if you learned something, let me know if there's any other questions you want to see from the book, from WebAssign, from class. Go ahead and hit up in the comments. Like and subscribe. Just let me know what I'm doing, and I'll try to make more for you guys. All right, thanks.